Fire test under natural conditions, executed in Bad Salzungen, Germany. What looks like a high-tech construction site is in reality the preparation for a fire test. This apartment building will soon be destroyed, but first it will serve a helpful purpose. Bad Salzungen, located in Thuringia, Germany, is to be the place where a fire test will be executed under natural conditions. Several different fire protection systems will be tested here in a realistic setting. First, the protection systems for cable installations in floors and ceilings are installed. As is customary in buildings, the cables run vertically and horizontally through neighboring fire compartments. Experience shows that cables may act like a fuse in a fire if the fire spread is not prevented, or if wall or ceiling penetrations are not secured. Free space in the penetration areas in walls and ceilings are closed by the SVT staff with mineral fiber penetration seals, the Pyro-Safe Universal Bulkhead Combi S90 and the Pyro-Safe Flammotech Bulkhead Combi S90. But what is a test without comparative data? In order to receive comparative data, one high-frequency broadcasting cable remains unprotected. Two others are equipped with the ceiling system Pyro-Safe Power Cut. Realistically, the cables are installed vertically. Stock taking before the test. All protective systems have been installed. Several measuring nodes have been installed. They will record the temperature data during the fire. Staff of the material testing facility in Leipzig are gathering the data centrally. On the floor of the testing ground, there are 3 tubs filled with isopropanol. Following their ignition, they simulate the developing fire, which will further develop by igniting the pile of wood to become a full-fledged fire. The testing room is protected with fire-protective glazing from the company Schuko. The following systems are to prove their worth in the test. The Pyro-Safe Universal Bulkhead Combi S90. It consists of 2 special mineral fiber boards and intumescent fire protection coating Pyro-Safe Flammoplast KS1. The Pyro-Safe Flammotech Bulkhead Combi S90 is a similar system but equipped with an ablative fire protective coating which is especially fitted to be used in areas with a high level of moisture. Both ceiling systems can be used in walls and ceilings, and both systems support cables and cable trays as well as combustible and non-combustible pipes being led through the same opening. Later installations of cables and pipes are easily done with these ceiling systems. The Pyro-Safe Power Cut system seals broadcasting cables as well as combustible pipes. In a fire, a horizontal cutting mechanism separates the cables or pipes and at the same time seals the cross-section tightly. A spread of fire is thus prevented. Let's have a look at the neighboring apartments that are wall-to-wall with the test room. Here next door and at the back side of the test room, the horizontal pipes and cables are protruding from the wall. This part of the wall is protected with the Pyro-Safe Universal Bulkhead Combi S90. In this apartment on the 3rd floor, directly above the test room, cables and pipes are protruding from the floor. These are also protected by the Pyro-Safe Universal Bulkhead Combi S90. The broadcasting cables end here. A good opportunity to have a look at their insides. Highly dangerous in a fire are the plastic distancers made of polyethylene between outer and inner copper pipe. Once they ignite, burning plastic will start dripping without hindrance. The catastrophic results of the spread of fire to a lower level became tragically visible when in August 2000, Moscow's TV tower was in flames. At 540 meters, the tower is one of the most prestigious buildings of the Soviet Union. It was only this afternoon that the fire could be extinguished. A desperate fight as the fire started at 400-meter elevation, but the firefighters could not reach the actual heart of the fire. The fire was caused by a short circuit. An automatic fire extinguishing system failed. The tower burned all night, clearly visible against the starry night sky over Moscow. It took 24 hours for the firefighters to gain control, and it looks like 4 people, including 1 fireman, lost their lives in an elevator that fell down. The tower is not threatened to collapse, the authorities state, but a part of the tower will have to be removed. Up there, communication devices of the intelligence service are placed, and Moscow's TV programs are broadcast from there. More than 10 million people without television, This is a technical as much as a political issue. But back to our fire test in Bad Salzungen and the installations in the apartment below the test room. The vertical broadcasting cables and the pipes are protruding from the ceiling. The pyro-safe power cut system is mounted for this broadcasting cable. In the testing room, the firefighters ignite the isopropanol in the tubes and set fire to the stacks of wood. Thus, an incipient fire is simulated. It will develop into a full-fledged fire, which reaches a fire load of 2,500 kilowatt hours. This matches the energy of a fire in a normally equipped living room. After just 5 minutes, the thermocouples on the floor show 130 degrees. In the center of the room, 450 degrees. And at the ceiling, 700 degrees. Also, just 5 minutes after ignition, the insulation of the unprotected broadcasting cable melts. 8 minutes later, the fire is at full energy. The temperatures have exceeded 1,000 degrees. The Schuko glass wall remains stable, but a simple glass panel 2 meters away from the Schuko wall cannot withstand the fire. It bursts. The testing room shows a real inferno. On the outside, the flames are reaching out of the window and up over the next level. In the level below the test room, the plastic distancers are meanwhile dropping fire. The spread of fire to a lower level now becomes clearly visible. The broadcasting cables protected by the pyro-safe power cut system do not show any effect. The system has long since cut the cable and closed the cross-section with the blade. After 40 minutes, the temperatures in the test room are falling. After 1 hour, the thermocouples are still recording 420 degrees on the floor, 530 degrees in the center of the room, and 570 degrees underneath the ceiling. After the room is cooled off, we are taking stock. By the 41st minute, the temperatures of this fire under natural conditions reached much higher values than those under standard testing conditions in the material testing facilities. The highest temperature was recorded in the 38th minute. The fire protection system's functioning has been proven in this original fire. It is safe to say that the systems can be recommended for use. When these systems are used, it is proven that a spread of fire will be prevented for a period of 60 minutes as demonstrated in the fire test under natural conditions, and more than 90 minutes as proven in standard fire tests. I can only suggest to the constructors to take fire protection seriously and to do what is mandatory and to follow regulations. It is always advisable to choose a competent professional company that offers products and systems with suitable certifications based on high-level tests, higher even than the strain of the original fire test. That is why I suggest not to overlook fire protection, even if it is expensive. There is nothing more valuable than human life, and so we should not be hesitant to spend the money.